LangGraph's interrupt mechanism enables dynamic execution pausing within computational graphs, allowing for external input integration while maintaining state persistence through checkpointing. This pattern facilitates human-in-the-loop workflows by suspending processing at arbitrary points and resuming with provided data. We're about to examine a node implementation that demonstrates proper interrupt usage, where the execution flow pauses to request user input before proceeding with potentially fallible operations, while maintaining clean separation between interruption points and error handling logic.
Def notice state. Hash good, interrupting first, then handling. Hash error conditions separately. Interrupt what's your name. Try. Fetch data hash this can fail. Accept exception as E. Print. Return state.
This code demonstrates a best practice for using interrupt in LangGraph nodes, specifically showing how to separate interrupt calls from error-prone operations. The pattern places the interrupt call first, before any potentially failing operations, ensuring clean separation of concerns. This approach prevents the interrupt mechanism from being accidentally caught by exception handlers, which would break the intended pause-and-resume behavior. The implementation follows the principle of keeping interrupt calls independent from error handling logic. By calling interrupt what's your name, before the try except block, the code ensures the interrupt will properly pause execution and return control to the caller. The subsequent fetch data call is wrapped in its own error handling, maintaining clean separation between user interaction points and operational error handling. This structure is particularly important because LangGraph's interrupt mechanism relies on exception propagation to pause execution, and wrapping it in exception handlers would prevent the intended behavior. The pattern shown here is production-ready because it adheres to LangGraph's interrupt rules. Interrupt calls are not wrapped in try-except blocks. They're placed before any operations that might fail, and the error handling remains separate. This approach ensures reliable pause-resume behavior while maintaining proper error handling for the actual operations being performed. Let's break it down.
Def notice state.
Defines a function named node that takes a single parameter, state, with type annotation state. The function signature indicates it expects a state object as input, but doesn't show any implementation or return value in this segment.
Interrupt what's your name.
Calls the interrupt function with the string argument, what's your name, which pauses the current execution flow to prompt the user for input with this question. The function likely handles displaying the message and waiting for a response, though the specific implementation details aren't visible in this line.
Try. Fetch data hash this can fail.
Attempts to execute the fetch data function within a try block, indicating this operation may raise exceptions that need handling. The comment explicitly notes this function can fail, suggesting error handling follows this segment.
Accept exception as E.
Catches any exception that occurs in the preceding try block and assigns it to the variable E for potential error handling or logging. This is a broad exception handler that will intercept all exception types, including both built-in and custom exceptions.
Print.
Prints the exception object, E, to the standard output, displaying its string representation, which typically includes the error type and message. This is commonly used for debugging to inspect what went wrong when an exception occurs.
Return state.
Returns the current state object from the function. This implementation demonstrates LangGraph's interrupt pattern in action, where execution pauses for user input while maintaining clean separation from error handling. The interrupt call happens first, ensuring it won't be accidentally caught by the subsequent try-except block that handles potential failures from fetch data. This structure preserves LangGraph's pause resume behavior while keeping operational error handling isolated. The pattern is production-ready because it follows the core principle. Interrupts remain independent of exception handling, allowing reliable state persistence during human-in-the-loop workflows.
The graph pauses to ask for names it already knows, while the state dutifully returns what was never missing.